Live. I'm recording you. All right.
YouTube.
All right. All right, here we go. The limits or the properties class, I will wait for when you are ready to proceed. So the properties of limits as x approaches negative infinity or positive infinity, they are the same as earlier, okay? So let's write out for limits as x approaches positive infinity or negative infinity, let's give it a function, f of x equals to L. And let's give it another function, limits as x approaches positive or negative infinity. Let's call it g of x now, equals to m, just like before, where L, m, and later we're going to use k for constant. It's in the set of all real numbers. Okay, so that's what I'm going to give us to start with. So just like the other set of properties, the sum, if I ask you to find the limits as x approaches positive or negative infinity, doesn't really matter, of two functions adding together, can you separate them? And then find the limits. Okay, so that's the same as before. Can you guys agree? Sure. Okay, so that's really just L plus M. Okay, so you can totally separate them. Then we're going to do the same thing for difference. Okay? Difference. So when you subtract, so if I were to ask you to find the limits as x approaches positive or negative infinity of two functions subtracting each other, as you remember, this is the same thing as, I'm writing it here and not the one above because I know we've seen this before. As you remember, we can do this. Okay? So that's just the same as what? Yep, L minus M is right. Okay. An apple a day keep the doctors away.
It was so small.
All right, product. We are pretty much, class, writing the same exact properties over again. Okay. So you can just say see whatever page you are using, but I'm going to spell it out for some of us that are not. Okay. All right, so as the limits as x approaches negative or positive infinity of f of x times g of x is the same thing as just what two letters multiplying another. That's right. Okay. And then the next one I'm going to write is quotient. And I don't mind. You can go and say, see properties from, what page was it on? 3. There you go. Okay. So f of x divided by g of x. Okay. That is the same as what? That's right. The same as what you wrote on page 3. Last one, we are going to, not last one, 2 more. Constant. Constant multiple. Let's use k for constant. Bless you. Okay. So as limit approaches positive or negative infinity of some constant, let's call k times f of x. This is the same thing as according to, that's right. K times f. Oh, look, I can't even write L. Okay, K times L. There you go. And last one, guess what your notes on page 3 said?
Power.
Power. What happened? You have a power. Okay. So limits as x approaches positive or negative infinity of some function. Let's raise it to power p. If I wanted to, I can find the limits of just simply f of x first, right? And then raise it to a power later, which is really just what to the what? L to the p. All right, let's put it to use. Example trace.
Holy cow. Oh, I love these questions.
What is the point in calculus for us to find the limits, as you can see here on example 3, as x approaches infinity or x approaches negative infinity? What is really the goal behind this? To define what? Yeah, to see or to prove that we have an asymptote or not. Oh, okay. Well, then maybe let's just review that first. Okay. In algebra 2, that's when you learn this. Let's do a big old bubble over here. Make up some equation. F of x equals 2x to the second plus 300x minus 1 all over x minus 1 times x plus 2. Okay, I just made it up. I don't know if that's going to work out or not, but we'll figure it out. Question number 1. What do you guys remember, or how do you find the vertical asymptote?
Oh, it was the
Vertical ones?
Vertical ones.
You figure out what factors the bottom makes
This one's
zero.
doing like the
Let me let the chart goes by. Yeah, remember vertical goes like this, right?
Yeah.
If it goes like this, would you agree that it runs over the x-axis?
Yes.
Right. What's the point in algebra 2? Why did we have to find the vertical asymptote? Yeah, the reason we found the vertical asymptote because there are certain values that x were not defined. Would you agree? Yeah. So if you look at this, is the domain all reals? No, you have a fraction, right? You have a denominator. The denominator can never ever be 0, right? So you take the denominator. What makes the denominator 0? What two values in this case, really?
1 and negative 2.
Yeah. So guess what those were?
The vertical asymptote.
Yes, you're right. Okay. So your VAs, vertical asymptotes, are you take your denominator and you set it equal to 0, and you found 2 of them in this case. X equals to 1. And this is just a review. You should already know this, right? No? Maybe? No? Okay. All right. Now, remember back in the days, you also learned how to find horizontal asymptote and oblique. So we're just going to deal with horizontal asymptote in here. What do you remember?
Degrees of each. I don't know what to do after that. It's the same. It's like, which one's bigger, which one's smaller.
You're right, Kayla. It is right. Okay. Remember those are called end behavior? Okay. And let's break this down to smaller functions. Forget the scary rational functions. Let's just take the numerator only, which is a quadratic, right? 2x squared plus 300x minus 1. Let's just take that equation only. What is the end behavior of that numerator? Up and up, right? The right goes up. Remember this?
Yes.
Because it opens up, right? So up and up.
As approaches infinity.
Right, okay.
Infinity, I don't know.
So this is 2x squared, and it's positive, so it opens this way, right?
Yeah.
So back in the day, we say, in algebra 2, you say up and up. Now, but that's the end behavior, what it behaves like at the ends, okay? What if you were to ask the function of the end behavior? Okay, so that's what it x approaches, but just the function. So when you hear or when people ask you, well, what's the end behavior? Then you tell people, well, it's up and up. But end behavior function is an equation, okay, that mimics or behave like this as x approaches positive infinity or x approaches negative infinity. Okay. So if you look at the numerator, would you agree that if x gets to be really, 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 really big, what's the only term that mattered? x gets really, really big. What's just the numerator right now? We're going to focus on one thing. Yeah, would you agree the first term is the only one that's going to have some significance? X is like 100 billion. Is this 1 going to matter?
No.
Yeah.
Is this 300 going to matter? Not really. Okay. Remember, you have to imagine that x is really big. Whatever your infinity is, my infinity can't hit your infinity. Okay. So think about, you know, Bill Gates' money, or now Jeff Bezos. He's now richer than Bill Gates, right?
Amazon.
Yeah, he's the Amazon guy.
He's 100 billion.
Right. So if he's that rich, he's going to give away $300,000, $3 million. It's not going to matter. He's going to go around and throw a dollar away with no problem at all. So when you're talking about when x is really big, okay, so team, when x is really big, the end behavior model, the word model means what? An equation, a function. It's always this term, okay? It includes the leading coefficient with it. Now, so that tells me that is the end behavior model. Okay. Now let's focus on the denominator. What is the end behavior model for the denominator?
X squared.
X squared, right? So if I were to multiply it all out, the powerful function is x squared. The first term, if you arrange it in order. Are we okay so far?
Yes.
Great. Remember back in the days, and then some of you mentioned this already, to find the horizontal asymptote or oblique, you take the end behavior on the top, you divide by the end behavior on the bottom. Remember this? That's what we do with HA, okay? So on HA, you go, well, what's the end behavior on the numerator? 2x squared, right? What's the end behavior on the bottom?
X squared.
Right, reduce that down to?
2.
Right, that's a horizontal asymptote. Okay? That's what you're supposed to learn back then.
I didn't see that. I don't remember.
It was so much harder.
Yeah, I love. So I thought it depended on the degree, and then from there you decided what to do.
Depends on the degree, you're right, if oblique was involved. But we're just talking about horizontal asymptote.
So should we just kind of oblique?
Yeah.
We don't need oblique for right now. Okay.
Right now, so it's
What is it when it's like this denominator stays in the numerator?
Well, the thing is, oblique means, okay. Well, think about this. Horizontal goes this way, right? Vertical goes this way. Oblique is what?
Diagonal.
Slanted, whatever. The reason that you would have oblique at all, if you were to take the end behavior of the top and you divide it by the end behavior of the bottom. The only way that you would have a line that's not horizontal or vertical if there's an x left over. Does that make sense so far? For it to have an x left over, the numerator, the degree of the numerator will have to be 1 more than the degree of the denominator. I made this up, obviously, so that we can have a horizontal. All right, so that's what you're supposed to do. Now, this right here, y equals 2 is now called, or then 2, called what? Horizontal. Now let's go further with horizontal right now. With the vertical, because that's what x can never be, so you or your function would never intersect your vertical. Does that make sense so far? The horizontal, though, at times you can intersect. Okay? So I don't know if you guys did this in Algebra 2 or not, but did you guys test to see if the function intersects or not intersects HA? No. Okay, maybe that's just something some teachers do. Okay, so don't be surprised if your graphing calculator shows that it intersects and then it goes back. Okay. So the definition of asymptote is just what the function approaches. It does not mean anything about intersecting or not intersecting. Is that clear? Okay. Now let's move on and do this one. For the function y equals x times sine of x plus 2 sine of x all over 2x squared. Find the limit as x approaches infinity of y. So what would you do if this is in your homework? Graph? Split. You're right. It doesn't say calc, so you can't use a calc. So let's split it up. Here we go. x times sine of x, split it over here to 2x squared, plus the limits as x approaches infinity of 2 sine x over 2x squared. Okay, now that you did split those two things, what would you like to do next?
Do the horizontal asymptote.
That's what we're trying to get to the vertical asymptote, really. What do you do now? What do you see? What should you always do? You have to simplify.
Oh, I knew that.
Okay. So when you simplify, the first function has sine of x over 2x. Is that true?
Yes.
The second function has what?
Sine of x.
Sine of x over x squared. Thank you. Okay. Now I'm going to pinch this because I'm going to bring it up above. We kind of did something very similar to this the other day with the calculator. Okay. Can you guys see this right here? What did we do with this? What? Which one is it? Ah. And we talk about that a lot then too, right? Why was it 0 then? Let's recap it really quickly. So let's talk about why it was 0 then. Let's review really quickly. As x approaches positive infinity, right? Both numerators have sine of x. Can you guys see that? Okay, so let's take, what's the highest the sine of x can go to? 1. What's the lowest?
-1.
Yeah, so we'll take the two extreme cases, okay? Positive and negative 1. So x approaches, let's say, 5,000 this time. Sine of 5,000 without a calculator, would you agree that you would not know what it is exactly?
Yes.
Well, you know the height is somewhere in between -1 and positive 1. Anywhere there is fair game. Now on the bottom, would you agree that that's 2 times 5,000?
Yes.
Which is a really, really big number, right? So you can take a -1 divided by that big number, which is what?
Some really small.
Some very small negative number, right? You can take a -half. But remember, it's a fair game on the top that is from -1 all the way to 1. You take -0.5 divided by that big number again. It's still a small negative, and positive half and positive 1. Doesn't matter what you divide or what you take, right? The height is going to get closer and closer to what? 0. So that's why that limit, thank you. That's what that limit is 0. Okay. So that is 0 plus what? Oh yeah, this one is more 0, right? It's getting closer to 0 even faster. Can we agree?
Yes.
Yes. So that's 0. So what is this?
0.
Because the limit as x approaches infinity 0, what can you say? Is it an HA or is it a VA? HA. There's an HA at y equals to what?
0.
Yeah. That's why we find infinity. I mean, that's why we find the limit as x approaches infinity. So we know that we can find HA. Because if you think about it, the one I made up over here, it's easy to find HA, right?
Yeah.
Pick the top. How about this one? Is it easy?
No.
No, you don't know which one is more dominant. How would you know? So that's what limits is created. So that way, when we can't find it algebraically, you go and use limits. Okay. Now, let's do it when it's approaching negative infinity. Okay, because that's what it asks you to do. Limit as x approaches negative infinity. Is it the same?
Yes.
Okay. I'm not going to write the first step again, but I'll write the second step. Okay. So I heard a couple of you said, oh, it's still 0. Is that still true?
Yes.
Yeah. Okay. It's still 0 plus 0, which is 0. And again, your HA, it's always this value if it exists. Okay. Another question. Do you think these two, x approaches negative infinity and x approaches positive infinity, will always be the same? No, just because this example is doesn't mean it will always. Okay. All right, let's move up really quickly. So now you know how to find horizontal asymptote algebraically and limits way. Vertical asymptote. You already know how to find it algebraically. Let's define the limits way. If the limit of some function, let's call it f of x, as x approaches an a value from the right, equals positive or negative infinity. Or the limit as x approaches some value from the left of a function equals to positive or negative infinity. Then, if that is true, then VA, vertical asymptote, is just simply x equals to a. Can you see the relationship in vertical asymptote and horizontal? What's the only difference? The horizontal asymptote wasn't this x approaching infinity, and then equal to a value, right? But this time the vertical, we're like switching that, okay? And the reason is, if you think about it, back then when you were graphing these by hand, wasn't it always something like this, like that or like that, right? Yeah. So if x is approaching some value from the left, it's either going towards a negative or positive infinity or the right. Okay. Do I have to have both for me to have a VA? No, right? One is good enough. So let's practice. Here we go. Use graphs and table, that means calculator, to find the limit as x approaches to from the left. So try it out. Make sure you know how to use a graphing calculator, right? So just in case on test days they usually calc and non-calc. What's happening to the graph? As x approaches to from the left-hand side. Only one person has a calculator in this group? Dead, dead, and dead. Oh my. Do you have a charger? Oh, in your house. I want to make sure you have one. Hey, what did the calculator say? Positive and negative infinity, or does it have a value? Negative infinity? I don't know. Let me bust out my Desmos. Negative infinity? All right, let's call decimal, if decimal's coming up at all. Oh, there you go. All right, here we go. Okay, so here it is, right? So x equals to 2 coming from the left. What's happening to the height?
Going down.
All right, so that is definitely negative infinity. It's the answer based on your graphing calculator. So that if that's on the calculator portion, just write the answer and done. Okay, next one. Calc or no calc? No? Does it say use graphing tables?
For the function, it's very different. The graph is very different.
Okay. Let me move on. All right, here we go. For the function, f of x equals x squared minus 1 all over 2x plus 4. Part A, find the vertical asymptotes of the graph. If it says find the vertical asymptote, do you have to use calculus?
No.
No. Can you use algebra? Yeah. Go and use algebra and find it for me. Find the vertical asymptote. How many do you have? One. Okay. What do you do to get -2? But don't forget, you need a variable, right? X equals or Y equals? X, okay, because it's a vertical. It crosses the x-axis. Okay. All right, Natalie, what did you do to find the vertical asymptote?
I set the denominator equal to 0.
Yes, you did an awesome job. All right, so is that true? Great. Okay. Part B says, can you help me read part B, please? Macy is not here. So, Kylie.
Describe the behavior of the function of x to the left and right of each vertical asymptote.
Okay. What do you think we should do? Yeah, you're going to have to verbally tell me, right? But since if it's a test question, then you won't be able to tell me verbally. You just write it out. Tell me the behavior of this function, okay? On the left hand and the right hand of the asymptote. In this case, vertical asymptote. So guess what you do? Now you take the no calc, because it doesn't say use a calc. You will do what?
Graph it in your head.
You can totally graph in your head, or I just taught you a theorem for a reason.
What about that whole thing with the first value and then dividing and then finding?
That's your horizontal asymptote. This one it says describe the behavior of the function to the left and right of each vertical. I just gave you a theorem, didn't you?
Separated.
What are you going to do here?
Separated.
No, not yet. Tell me what to do first.
Right, it doesn't limit.
Yeah, you have to use limits. That's the only way, okay? Find the limit as x approaches -2 from the left of, what is my function, x squared? X squared minus 1 all over 2x plus 4. And it also wants the right, so find the limit as x approaches -2 from the right of the same function, okay? That's what it wants us to do. All right. Now, let's talk about how to find the limits of this. What should you do? Should we separate them?
No.
If I do separate them, would that help? Not really. Pointless? Okay. Plug it in. You're right. What should you plug in?
But then it would just, you would
You're right. Doesn't exist. You're right about that.
So you use one of those really weird things. Well, I'm just guessing a lot of people want separated.
Okay, so let's talk about -2, okay? And I'm looking for the left-hand derivative of -2. What is the value that's so close to the -2, but on the left-hand side, -2? Not -2, because I can't plug that in. Yeah, let's do that, okay?
Yes, let's do it.
Visually, okay. I'm going to plug in, or I'm going to choose a value, x. I'm going to choose what, like -2.001. Is that okay to pick?
Yeah.
Is that on the left-hand side of -2?
Yeah.
Sure it is, okay?
Absolutely.
Here we go. Square that for me. And remember, you don't have a calculator, okay? Because I'm going to plug it in. No, don't give me an exact value. I don't care what the exact value is. What's -2.001 squared? Bigger or smaller than 1?
Bigger.
All right. -1. Is it still bigger or smaller than 1?
Bigger.
Okay, can we agree that the numerator right now is positive and it's bigger than 1?
Yes.
Do I care if it's more than that?
No.
Not really. Okay.
Three.
Okay. Are we okay with how we came up with the number that's bigger than 1 on the top?
Yes.
I'm going to pause right now. If you don't, please ask. So I can totally work it out. Okay. Now the bottom. So all we know right now is the top is a positive number bigger than 1. The bottom, I'm going to take it and multiply by 2. Bigger or smaller than 4?
Small.
It's a negative number for sure, right?
Yeah.
Okay, but pause. It's -4 point some change.
Yeah.
Plus 4
Yeah.
is now a negative, very, very small number. I'm going to pause right there really quickly.
Oh my goodness.
-4 and some change plus 4 is now a negative small number.
Yes.
On the top, we talked about having it a number that's positive bigger than 1.
Yeah.
So you have a positive number divided by a negative number that's small. You're going to be going towards a big number. Which direction?
Negative.
Negative
Oh, it was
infinity.
right. It is negative.
Okay.
I didn't know to do that.
Okay. Okay. So I'm going to spell this out. Here we go. When we plug this in, okay, when we plug in negative 2.001 or whatever value you want to pick, on the top, did you guys get a positive number or a negative number?
Positive.
Positive, right? Positive number, I'm going to spell it out, greater than 1, yay or nay? That's all I need to know, okay? And then when I plug it in, what was the bottom number? Negative number less than 1, very close to 0 as a matter of fact, right? Negative number close to 0, it's true or false? Yeah, okay. So when you divide them, you will get a negative infinity, okay? So that's what's happening, because the reason is that I can't plug in straight up negative 2. I have to find something nearby. All right, how about this side? What number should we pick? Negative 1.99, whatever, right? Should we do the same thing? Yeah, negative 1.99 something square. Positive and negative. Bigger than 1 or less than 1? Bigger. When I subtract 1, am I still going to have a positive number bigger than 1?
Yes.
Yeah, that's all I need to know. I don't care what the exact value is. Are we okay so far? Okay. So on the top, I'm going to spell out number that is bigger than 1. Okay, I don't really care what exact value is. Now, on the bottom, when I take it and multiply, negative 1.99999 times 2. It's a negative number, right? A negative what? Negative slightly smaller than 4. Which I'm going to add to 4, so now I'm going to have a positive small number, very close to 0. Would you agree?
Yeah.
But this side wasn't. Okay. Yeah, so. Like negative 3 points, like, you know, whatever. Okay. Yeah. All right. Positive number close to 0. So when I divide something that's positive on the top, greater than 1, divide by something so small, what's happening? This is, you're right. Okay. So now we're going to spell out. We're going to spell the answer because we haven't answered it. Tell me the behavior of the function on the left-hand side and the right-hand side of the vertical asymptote. What would you say? No. As x approaches negative 2 from the left. Okay. F of x, what? Approaches. You're right. Negative infinity. And as x approaches negative 2 from the right, f of x approaches what? That's right. And that's an egg roll.
Yay.
Good job. Good teamwork, guys. Oh, you guys are still listening? Oh, yes. Spring summer 18.